You gave the model more information, and the answer got worse. Not different. Worse. You pasted in the whole document, the whole thread, the whole file, and the shorter version of that same question somehow got the better answer. You are not imagining that. In one measured evaluation of 13 models, all advertising very large context windows, 11 scored below half of their own short input baseline once the input hit 32,000 tokens. The window was nowhere near full. And here's the part almost nobody sees. On a real application call, most of what the model reads, you never typed. Almost everyone treats the context window as a container. It has a size, you fill it, more is better, and when it overflows, the model forgets. Our context window episode covered that part, the forgetting, and the whole transcript being reread every turn. Take it as given. This is the level above it. A window is not a container you fill. It is a budget, several claimants are already spending it, and your question is one of the smaller line items. Picture a briefing folder you hand to a brilliant freelancer who has never met you and forgets everything the moment they leave the room. Every page you add competes with every other page in it. So open the folder. On one call to a modern AI application, roughly 8 things are competing for the same space. 1. The system prompt, the standing instructions the builder wrote. 2. The tool definitions, every connected tool's name and description and parameters, present on every call whether that tool gets used or not. 3. Retrieve documents, the search hits and file contents, which is where retrieval augmented generation lands. 4. Long-term memory, saved facts pulled back in. 5. The conversation history, the entire prior transcript sent again. 6. The raw output of every tool already called, usually the fastest growing part of the folder. 7. The format the answer has to fit. And 8. Your message. In a serious application, your message can easily be under 5% of what the model actually reads. So why does adding pages to that folder hurt? 2 reasons, and they point the same way. First, attention. In a transformer, every token gets compared against every other token, so n tokens create n-squared pairwise relationships. Anthropic's framing is that a model has an attention budget it draws down as context grows. Second, training. Models saw far more short sequences than long ones, so, in their words, they have fewer specialized parameters for context-wide dependencies. Keep their hedge attached, because it is the honest version. This is a performance gradient, not a hard cliff. We did the architecture of long windows in the million token episode. This is what to do about it. And it is a finding, not a vibe. 3 separate lines of evidence. A widely cited study from 2023 found accuracy tends to be highest when the relevant information sits at the start or the end of the input, and drops significantly in the middle. The benchmark from the Hook, published in early 2025, put a leading model of the day at 99.3% on short inputs and 69.7% at 32,000 tokens, on questions whose answer shares almost no literal words with the question. And an independent lab ran the same questions 2 ways across 4 model families, once in a focused input and once with the answer buried inside 113,000 tokens. The focused version won in every family. 1 convincing wrong answer planted in the pile lowered accuracy, 4 lowered it more. Now the result that should change how you work? In the same report, the filler was not wrong. It was coherent, logically ordered material on the same subject. And the models did better when that filler was shuffled into nonsense order than when it was left coherent. Read that twice. Well-organized relevant context scored worse than randomized context. The lab's conclusion is the line to keep. Whether the relevant information is present is not all that matters. What matters more is how that information is presented. So the job was never gathering. It is curation and layout and deletion. And the teams furthest ahead are deleting hard. The Claude Code team reports cutting roughly 80% of that product's system prompt for its newest models, while the older ones keep the full prompt, and removing its built-in search tools in favor of a plain command line. The name has a history worth getting right. In January 2023, Riley Goodside split prompt engineering in 2 and called one half context engineering. Nearly 2.5 years later, in June 2025, Toby Lutke proposed the term over prompt engineering, and Andrej Karpathy amplified it 6 days later with the definition everyone now quotes. Neither man coined it, and neither claimed to. They popularized it. That July, an academic survey pulled more than 1,400 papers under the label. By September, a major lab published a formal definition, calling it the natural progression of prompt engineering. One agent company calls it effectively the #1 job of engineers building AI agents. The work did not disappear. It moved from choosing words to designing the whole payload. So what do? 4 moves, all 4 operations on one budget. Select, compress, isolate, write. Select means pulling in only what this step needs, at the moment it is needed. Hand over the call number, not the shelf. One lab reports that loading tool definitions on demand takes a 50-tool payload from about 77,000 tokens to about 8,700, with accuracy on their own tests going up, not down. And the move has a ceiling at both ends. One recent preprint finds the move wins only once the material is too big to just read through, and a second layer of routing on top never helps and can break accuracy outright. Compress means keeping the decisions and throwing away the raw material, meeting minutes, not the recording. Summarize the run so far, open a fresh window holding that summary, continue. On one major platform, it is now a switch you can turn on, and once it is on, the model summarizes by itself when the input passes 150,000 tokens, even though the window holds a million. Isolate means giving the messy work its own window. Send a researcher into the library and get back a one-page memo, and you never see the library. In the documented design, a sub-agent burns tens of thousands of tokens exploring and returns often 1 to 2,000. Write is the opposite direction. Put the state outside the window so that starting over is survivable. A running file of what is done and what is next is the lab notebook that survives the shift change. And notice what the four have in common. Retrieval, summarizing, sub-agents, and memory are 4 separate episodes on this channel. They are not 4 topics. They are 4 operations on one budget, and knowing which one a bad answer needs is the skill. None of this requires you to build anything. 4 things you can do in a chat window today. 1. State the whole task in one message instead of dribbling it across a dozen turns. Across more than 200,000 simulated conversations, splitting a fully specified instruction over multiple turns costs an average of 39%, and what you lose is mostly reliability. 2. When a thread goes wrong, stop patching it. Open a new one with a corrected brief, because every wrong turn is still in the folder being reread. 3. Paste the 2 relevant sections, not the 40-page document. That is the focused input experiment, and the only cost is deciding which sections matter. 4. Audit your standing instructions and delete the stale ones. Vendors report that contradictions cost real quality, and that long lists of "do not do this" can backfire on their newest models. Now the honest limit, because this discipline is about a year old at any scale, and it shows. The same lab put compaction first, then found it was not enough on a long build and moved to clean resets with a handoff file. Months later, on a newer model, they dropped the resets and went back to letting it summarize. The lever keeps moving because the models keep moving. There is still no agreed definition. One camp means curating tokens, another whole systems. A third says it is prompt engineering under a better name. Several of the numbers here are vendor internal evaluations, and the cards on screen say so. And the biggest question is open. One team reports a large win from splitting work across isolated agents. Another argued, the same month, that at the time collaborating agents made fragile systems, the decisions get scattered. Meanwhile, models keep improving on long inputs, and one major vendor shipped a 1 million token window at standard pricing this year, while others still charge a premium past a few 100,000. Scope all of this to mid-2026 and expect it to move. So here's the skill, shape so you can carry it. When an answer is bad, stop rewriting your sentence and look at the folder. Name what is in it, from the system prompt and the tool definitions, through the retrieved documents, memory, history, and tool outputs, down to the output format and your own message. Then pick a move. Select what the step needs. Compress what is already spent. Isolate what is messy. Write down what has to survive. You are not writing a better prompt. You are packing a better folder, and deciding what to leave out is half the job. This is episode 1 of Put AI to Work, our season on getting real work out of AI agents, 1 working skill per episode. The full free AI course is on the channel. Subscribe, and the next bad answer will look like a budget problem, not a mystery.